Hello, it's Keith here, and this is lesson 4 of the Photon series. And Photon is, of course, my little Tron clone. You can see it here. We're going to be going over some more of the code today. We're going to be looking at the screen draw code, which is drawing the border you can see here, and the information in the corners. We're going to be looking at the game over screen and the level initialization, and that is where we work out where we're going to place all of these objects you can see, which are our obstacles. And the game over screen, if I just kill myself a few times, is this where we show game over, and we record if the player has got a new best level or not. Okay, let's go over to the code and we'll discuss it then. Here we go. So we're going to be looking at the sections from here, this level initialization. Now, this is run at the start of every new level, whether it's the start of a new game or when you've won a previous level. So the first thing we're doing here is we're checking the level number, because every 7 levels we're going to give the player a new life. Good for them. So we're just checking here by masking the bottom 3 bits of the level here, and we're incrementing the life counter if we're at level a multiple of 7 here. Now, what we're doing next is we are going to reset the boost power. Now, the boost power is set to about 200 here. Now, the way the boost power basically works is the amount that's shown on screen is half the amount stored in the variable. The boost power is, of course, when you hold down fire, you move at double speed. So the shown value is actually half the stored value. That's why we've got it times 2 here, just for clarity. And the amount of boost power is lower on the small screen systems like the Game Gear, because you simply don't need to move as fast to get from one side of the screen to another. So you get half as much. Next, we're going to work out the AI of the computer. Now, the AI in this game is very, very simple. The CPU will look ahead a few pixels, and then it will see if there's an object there, and if there's something it's going to hit a few pixels away, it will choose a direction to turn in. So the further ahead you're looking, the easier it is to kill the computer, because if the computer's looking here and you drive in here, it will not notice and it will crash straight into you. If the look ahead is very close, so it's looking just 1 pixel ahead, and you move in here, well, it's still going to spot you and it's going to get out of the way. So effectively, higher numbers mean it's looking further ahead, but it's actually more stupid. A look ahead of 0 means it's going to make very, very tight turns right against walls, and it's going to be very hard to trap. So here we're working out what the AI level is going to be based on the level number. We're just shifting to the right twice, and we're subtracting from 7. And if we've gone below 0, we're going to cap at 0 here. So we're storing the CPU's AI just there. That's the calculation. Okay, next what we're doing is we're copying user RAM back over user RAM. Now, that might sound a bit odd if I just find the data defs. What that's actually going to do is it's going to copy these settings over some of the player settings, effectively setting the start position of the player and the CPU and the start direction. So we're basically resetting the player's positions, the user and the CPU, and then we're setting their directions so that the CPU starts going left and the player starts going right. So that's what we're doing there. We're then clearing the screen, and now what we're going to do is we're going to calculate how many obstacles are on the screen. And again, this is based on the level number. Now, there's 2 kinds of obstacle we use. There's a simple square, which is a solid object with a cross in the middle, and there's a more complex object, which is effectively 4 corner pieces with a hollow bit in the middle. And you can sort of, if you're very clever, you can sort of navigate through the middle bit. It's quite a complex object. Now, there are up to 10 iterations of the simple object. We draw 2 per time. I'll explain those in just a moment. And then any remaining ones we draw of the complex object. So there's 2 versions here, and we've got a count of 10 limit for the first object, and anything else is the more complex second object. So we're working out how many objects we're going to draw based on the level here. We're setting our scale because we're going to use C packets, the compressed vector packet format for these objects. And then we're going to draw the objects here, and we're drawing them in pairs. And the reason for that, as I explained before, is we've got 2 pieces of code to pick a random position. One will do a horizontal object, which is the full width of the screen but a narrow height, and the other is a vertical object, which is the full height of the screen but a narrow width. And this effectively creates a kind of cross shape. The reason for this is we want player and the CPU to not immediately hit an object as soon as the level starts. So that's a simple way of doing that. We're controlling the random positions of our objects by using those 2 different versions. So we're drawing 2 objects per time here, and then we're decreasing the object count and checking that object limit. So if we've drawn all the objects we're going to for this level, or if we've drawn the limit of 10 for the first kind, we're then going to slip into this second routine and draw the second object kind, which, as I say, is that sort of more complex object with the hollow middle that we can kind of travel through. So that's what we're doing there. Those are the two versions. And then we're going to draw the borders. Now, there is a bit of a technical limitation with the line drawing routine of the code here. The way it's programmed, it can only draw lines of up to 256 pixels in length. It can draw at any position, but the length has to be under 256 pixels. So it's not really appropriate to draw a 320 pixel wide screen. So we're not using that. We're going to do it manually. The screen width here could be 320 pixels here. So we're doing it via presets here. So here we're drawing the two horizontal lines, and here we're drawing the two vertical lines, drawing our square. Then what we're going to do is we're going to show some pieces of text in the corners of the screen. We're showing the lives here, we're showing the level here, we're showing the CPU AI here, and we're showing the boost power. Now you can see these here. This is the boost power here, 99. This is the player lives here. This is the CPU AI here. This 7 is the stupidest, remember, and 1 is the current level number. So we're drawing these in the corner here. And then what we're doing here is we're drawing the little boxes in the around the text so that the player can't drive into the text. So these again are just some simple routines. These times we are using draw line because, as I say, the code can quite happily start at pixel 300. It just can't draw a line of 300 pixels wide. It's a limitation of the code because of the way the line drawing routine is working. So that's an unfortunate limitation. But as I say, the line drawing routine worked well enough for this, and I thought it was unnecessary to make it more complicated for the very small occurrence that I would need a wider one, because a lot of the systems I use are only 256 pixels wide anyway, and in my newer programs I'm actually limiting the screen width of the bigger systems like the Amstrad CPC to 256 pixels wide because it does make the programming a lot easier. Now here's the show boost power code that draws the boost power to the screen. So basically it's just a location command followed by a show decimal. The reason we've got a function to do this dedicated is because we need to remove the old boost power when the player holds down fire. Most of these variables don't change during the level code, but whenever the player presses fire we need to change the boost power, and the way we do it is we write the old boost power in color 0, deleting it, and then the new boost power in color 3, I think it is, I can't remember, and that will show it. Now we're shifting the boost power to the right ones because we effectively actually show half the value, so that's what we're doing there. And then we've got the game over routine here. So we're clearing the screen, we're resetting our scale depending on the screen size, setting our color, and we're showing the game over message here. And then we're just checking if the current level that the player's on is better than the highest level they've currently reached. And we're either showing an amazing you rock message or a terrible you suck message. Very simple, just a bit of fun there. If the player's doing better, we give them a nice message, and if they're not, we give them a nice insult. So just a bit of fun there to make the playing of the game a bit more amusing and to give it a bit of a feel of a legitimate game. As I say, it's only something simple for a bit of fun. So that's it. That's all we're going to be covering today. Now, if you were feeling adventurous, you could maybe improve the level definitions, make some nice, more exciting objects or some predefined level graphics. You could have some vector levels that you actually draw to the screen and then use those as your level map. The code here is just very simple using these random generated ones, so nothing too exciting there. But I think it's enough for a bit of fun. Anyway, that's all we're going to be covering today. The last lesson in this series is going to cover the CPU movement and the AI code, so that should be a bit of fun. And then we're going to go on to the platform-specific stuff. Now, the platform-specific stuff isn't particularly dramatic. It's very similar to the YQuest in the sense that we've got the joystick movement code that's very similar to YQuest indeed. But the important thing about that is we're going to be looking at how to plot pixels to the screen and how to read pixels from the screen on systems that don't necessarily have pixels, like tile map based systems that like the Master System, the Game Gear, that we have to do some tricks to get the game working on those. So I think that's going to be a lot of fun, and it's going to be quite interesting to you even if you're not interested in this game, because this is just a stupid silly little game, but it's got some interesting principles behind it. Anyway, I hope you've enjoyed this episode. If you have, like and subscribe and all that great stuff, and of course go ahead to go to the website, download the code and make something your own out of it if you want. Thanks for watching today, and goodbye.